is negative sine u du. And that negative is just sitting there already, so let me just put it there. And, well, this just works out perfectly, right? This becomes 1/2. The numerator is just dw. dw, negative sine u du, and the bottom is just w. So this is a natural log problem. And then the answer becomes 1/2 natural log absolute value w plus c. But w was really cosine u, so this is really 1/2 natural log of cosine u plus c, and u was really 2 over t. So this is really 1/2 ln absolute value cosine 2 over t plus c. And people will often not leave it like that because, like I was kind of saying a minute ago, the 1/2 coefficient of the natural log, if you pop that up, it becomes ln of thing to the 1/2, which is the square root. And so probably you would find most people writing this as the ln of the square root of the absolute value of the cosine of 2 over t shot plus c. Okay. Woo. 3 more to go, and then we're done with this packet. Oh boy. Ah. Alright, 32. Okay, this is the thing I was saying. This is new material as far as I'm concerned. 3 over the square root of 6x minus x squared dx. Okay, before we can talk about what to do, we have to talk about what not to do. And you have to sort of exhaust every possible idea that you might have to get this problem done. And I guess there's really only one idea, which is we see that there's an inner function, which is 6x minus x squared. And so you would hope that you could just let u be 6x minus x squared, but that just doesn't work. Because then du dx is 6 minus 2x, and now you just don't have anything looking like that anywhere in your numerator, and so this just substitution is hopeless. So this is not going to be a simple matter of letting u be the inside there. So we have to do something else. Okay, and what's the motivation for this? I suppose that every quadratic function is really some sort of form of x squared in disguise. And so that deep understanding of any quadratic function can be achieved by completing the square. And that is in fact what we are going to do right now. We are going to complete the square inside the square root inside the denominator. Okay, let's go. First, the 3 is doing nothing, so I can take that out. And I have the square root of cha-cha-cha. Okay, I'll assume you're, well, I won't assume anything, but I would hope that you're very, very good at completing the square. Still, there are variant ways to do it, and I think the most organized way is to factor out this negative. So if I factor out this negative, I'm left with x squared minus 6x. And now being, quite sort of careful here to, something like that. Being careful to factor it correctly is negative x squared plus 6x. Okay, and I said I was going to complete the square, so now we're going to do it. What number goes here? Well, it has to be a 9. What have I really just done? Because of this leading negative outside the parentheses, I really just subtracted 9, so I need to add 9. So I just basically just subtracted 9 and added 9 inside the square root. What is going on? Well, this becomes then, therefore, 3 times dx over, this is the square root of 9 minus x minus 3 squared. Okay, well we've successfully completed the square inside the denominator, so what? Well now, okay, some people don't like to do this, but I like to. This x minus 3, I just want to kind of get it out of my face. So I'm going to let u be x minus 3. Then du dx is of course 1, so du is just dx. So this substitution is a little bit silly, but I like to simplify my life as much as possible. So this just then therefore becomes du over root 9 minus u squared. And that makes me a lot happier, because it's just simpler. Alright, well, that's getting better, but I don't know how to antidifferentiate du over 9 minus u squared per se. But there is one thing that is causing me to have some hope, which is if that weren't a 9, but were instead a 1, then I know what to do. And that's because the derivative of arcsine, as we reviewed in a previous video, is 1 over root 1 minus x squared. And so keeping that in mind, I see that I have almost arcsine here. What makes it not arcsine is that this is not a 1, but is instead a 9. How can I force that to 9 to be a 1? Well, with algebra. So what I'm going to do is, being very careful, inside the square root, inside the denominator, I shall factor out a 9. And if I factor out a 9, I'm left with 1 minus u squared over 9. The square root of 9 is just 3, so that 3 comes out and cancels with that 3. And so this just becomes du over the square root of 1 minus, but instead of writing this as u squared over 9, I will write it as u over 3 squared. And now you see, I guess, that we've sort of massaged. Have I made a mistake? Oh no, not yet. I've sort of massaged this up to a point where it's now looking very much like arcsine. Okay, but there's still one more step. I always, at least explicitly, do these steps, which is to let w, to pick a new variable that doesn't look like u, to let w be u over 3, in which case dw is 1/3 du. And if dw is 1/3 du, then that means I really need there to be a 1/3 up here. So I put in this 1/3, undo the damage with the 3 on the outside, and finally, this becomes 3 antiderivative 1/3 du is this is now dw over root 1 minus w squared. And I personally don't ever antidifferentiate until I am down to the bitter end. In other words, until I've reduced it to a basic formula. There's a basic formula which says that this is just arcsine w. And so that's really 3 arcsine. W is just u over 3, and u is x minus 3. So that's x minus 3 over 3 plus c. That is the final answer. Whew, that is pretty hard. But when you do a couple of them, it gets easier. Okay, we're going to do one more, I guess. This one's like even more annoying, I believe. No, it's just equally annoying. Okay, let's go. All right. So, number 33. Oh, yeah. What is the antiderivative of 4 over 4x squared plus 4x plus 65 dx? Once again, a simple u substitution is hopeless because if I try to let u be the denominator, when I take the derivative, I get some linear function, and I just have no linear function. So the only hope here is to do something else. And I guess once again, on the principle that I can really understand any quadratic function by completing the square, I'm going to do that now. So I'm going to take out this 4 because it doesn't seem to be doing anything. And in the denominator, I will complete the square. Okay, being very careful about this, I will factor out a 4. Alright, fancy people might do this a different way, but I think the most simple thing to do is to factor out a 4. And then that's x squared plus x. And then the 65 has just got no business doing anything, so I just leave it outside. Looks good so far. Well, one number goes here. It has to be 1/4. I put, because half of 1 is a half, so squared. So that has to be 1/4. And then 4 times a fourth is just 1. So now I just added 1, so I need to subtract 1. This is just algebra 1, but okay, you still have to do it correctly. So then this becomes 4 over, or 4 dx over 4 times x plus 1/2 squared plus 64. Okay, and I guess now maybe I can just divide by 4, and that's nice. So I get dx over just x plus 1/2 squared plus 16. Okay, and almost without even thinking, I'm just going to do a quick substitution of u equals x plus 1/2. You don't have to do this, but I like to do this. It just, to me, just seems simpler. Then du is just dx, and then it means that I can write this as du over u squared plus 16. Now what? Well, people who are paying attention now know that, because we've seen a problem like this before, in fact twice, that this is arctan looking. In fact, if that 16 were not a 16 but were instead a 1, then this would just be arctan u. So what do I do now? Sort of engage, arctan algorithm or whatever. Divide by 16, or factor out a 16 rather, in the denominator. So that gives me u squared over 16 plus 1. Take that 16 just out, I guess. So that's 1/16. And then I get du over, and then rewrite u squared over 16 as u over 4 squared plus 1. And finally, I let w be u over 4, so that dw is 1/4 du. And, well, I need a 1/4 in there, so I stick in the 1/4, put a 4 on the outside, and then this becomes 1/4 antiderivative. 1/4 du is just dw over w squared plus 1. That I know to be arctan. So that's why this is 1/4 arctan w plus c. But w is really u over 4, and u is really x plus 1/2. So this is really like 1/4 arctan x plus 1/2 over 4 plus c. You could simplify that, I suppose, if you want to. 2x plus 1 over 8, but seems good enough to me. Okay, woo! If you did this entire packet, you are now pretty good at antidifferentiation, and then we will become kind of even better next week. Goodbye.